So hello everyone. Today we'll be starting the vertical curve, and in first portion of the vertical curve there is a momentum grade. So what is momentum grade? So momentum grade is basically the grade on which the momentum gained by the vehicles at the beginning of the steep climbing section is used to overcome the road resistance due to the grade. Such as the vehicle is moving with certain momentum, right? It will be momentum, and this momentum is used to overcome the grade resistance that the grade will be providing on the vehicle. That is, obviously we have noticed as well, if we move in a very speed velocity is, and I will gain some momentum, okay. And like this in a straight portion we are moving in a very speed velocity and we are gaining some momentum, and suddenly some curve, some vertical curve, that means some elevation, some stiffness will occur here. But we don't need to change our gears, or we don't need to change the speed. We'll be moving along the along our own momentum, and we'll be crossing this small steeper portion. We have felt it that way in some cases, right? So that is known as the momentum grid. And how much length does our momentum gain along our straight portion would be able to resist this steep surface is known as the length of the momentum grid. That is, this grade is known as the momentum grid. That means how much distance, how much grade will our momentum that is obtained in a straight portion will be used to overcome the grade resistance is known as the momentum grade, and this is called the momentum grade, okay. So therefore any minor ascending gradient may be referred to as momentum grade. Like I said it earlier, this any minor ascending grade may be referred to as momentum grade if the same is overcome by the vehicle with the initial momentum, right? So initial momentum, the vehicle can overcome this grade, then it is known as the momentum grade. So this is practically significant when the steeper grade is encountered after the mild grade. So let us move forward. Like it is explained here, the maximum, and as I explained it, everything is written here. So let us derive this equation, okay. So assuming that the tractive effort developed by the vehicle remain constant, what is meant by tractive effort? So tractive effort is the power of the engine, simple power of the engine of the vehicle. Where the engine will be giving the power to the vehicle, it will be giving the power to the vehicle at the rear wheel. We know that at the back wheel, the engine will be providing power to the vehicle, and the main purpose of the front wheel is to only steer, and the back wheel is to provide the power. That's why what is the momentum m1? M1 means the momentum gained during the straight portion moving with the velocity v1 equals to m v1 square divided by 2, and it is multiplied by some coefficient that is known as the inertial coefficient. We need to multiply it, okay. And this is the momentum grade, and after crossing the momentum grade, the velocity will be moving with v2 velocity. So what is the mv2 square divided by 2 into b? So what is the change in momentum? M1 minus M2. It is given right as the difference in momentum is used to overcome the additional resistance due to the resulting grade. So what is, okay? Look here, okay. So this is the let me explain a bit clearly. So I'm moving like right this, okay, and this is the steeper grade. I'm having some momentum from this grade, all right, and this is called I max. This is the steeper grade, and this is called I, all right. So what is Imax will be from the same horizontal surface. So what is the additional grade that our momentum gain should be used to overcome? That is, this additional grade is used to overcome. So what will be this additional grade? That is Imax minus I is the additional grade that our momentum gain should be able to resist, okay. The difference in momentum is used to overcome the additional resistance due to the resultant grade. So this resultant grade is this, and this resultant grade it provides some grade resistance, and the grade resistance should be overcome by the difference in momentum. If not, then the vehicle will stop here, and we have to change the gear, we have to change our velocity or something like that, okay. So what is the grade resistance? What is this resistance? What is the resistance? Grade resistance is given as w into I max minus I. How it how it will be W into I max minus I? It is simple as a frictional resistance, we can say. So frictional resistance W will be in downward direction, and it will be tan theta. What is tan theta? Tan theta is the slope. So slope will be nearly equal to I max minus I, because theta is this gradient is very small. So tan theta will be nearly equal to theta. So W into theta. Okay. So what is the work done by this grade resistance? It will be L into W into I max minus I, because the length up to this portion is L. Simple. Grade resistance is not in vertical inclined surface. The grade resistance will be in the horizontal surface, which is equivalent to this inclined surface. All right. The length is not in this direction. Okay. The length will be in this horizontal direction. Like the like here. Look here. This is the momentum grade, and we assume that the length will be up to this direction, and it will be an equivalent length in horizontal direction, and up to that horizontal direction the change in momentum will be able to resist the grade. So change in momentum is equal to the work done in overcoming the grade resistance. So on solving it, we'll get the value of EL as beta b1 square minus b2 square divided by 2g I max minus I. In this case, we assume that the attractive force is constant. Okay, attractive force developed will be constant. So like this, the momentum grade is defined, and I think maybe I'm not quite sure about these things. You need to go through the book more detail to learn about this momentum grade more deeply. I haven't explained this topic more deeply, so please refer the book. Do read the book so that you can get a broader idea about this momentum grade. All right, let's move on to one question, and the question would be about what is the compensated grade. So let me explain what is compensated grade. Okay. So in vertical alignment, so what is basically vertical alignment is like this. This is the vertical curve, right? So in vertical curve, there will be two things. That is, one is curve resistance, and the another thing is grade compensation. So what is curve resistance? So we know that this curve resistance will be in horizontal curve, and grade compensation will be in vertical curve plus horizontal curve in but there is a vertical gradient as well, and there is horizontal curve as well. That means there will be gradient and there will be curve, horizontal curve. If we look into the plan, it will be like this, and if we look into the section, it will be like this. Okay. So there is gradient as well, and there is a horizontal curve as well. In horizontal curve, the gradient is also provided. Then there we need to do the grade compensation. So I'll be explaining how it is done. So let me explain this very in a simple way. So this is a vehicle. Okay. So this is the rear wheel of a vehicle. This is the rear wheel of vehicle. This is the front wheel of a vehicle. So while moving in a curve, the front wheel will get turned. So the vehicle tends to go in this direction, but the rear will always provide the tractive force. That is, tractive force is the force which is provided by the engine. All right. So the tractive force will be in this direction because the rear wheel doesn't turn. So that why it will provide the force in straight portion, straight direction. But due to the turning of the front wheel, the vehicle tends to move in this angle direction. So what will be this angle? Let us consider this as an angle is theta. So if my total tractive force produced by the rear wheel is T, that is in straight portion. So what will be this component? This will be T cos theta. And obviously, if this angle is anything, T cos theta will be always be less than T, right? So there will be loss in tractive force while moving along the curve. That is known as the loss. If there is loss, so this loss is known as the curve resistance. Okay. So let us go into the another portion, that is grade compensation. So what is grade compensation? Basically, I even said that earlier, that I'm moving along the vertical gradient as well, and I am moving, and in vertical gradient there is curve as well. So we know that if the ruling gradient is given as, okay, say 1 by 15. Okay, 1 by 15 is very used. Let's say 1 by 50. Okay, 1 by 50, assume it as 1 by 50. So ruling gradient is 1 by 15 is good. Okay, let me give it as 1 by 15. Okay, so ruling gradient is 1 by 15. That means this ruling gradient is for the horizontal portion of the road. It is not for the vertical portion of the road with even the curve, horizontal curve, because obviously the gradient will cause the loss in the tractive force, that is the engine force, the force which is provided by the engine to the rear wheel is called the, what we say, tractive force. So the tractive force will be lost while the vehicle is moving along the gradient, and further the core resistance will cause the engine tractive force to decrease furthermore. So that's why we need to compensate the grade. That means we need to decrease the grade so that our loss in tractive force can be reduced. If say ruling gradient is there for the road, then it is for the straight portion, right? But turning causes curve resistance. In turning, it causes the curve resistance. We know about it. And so we need to decrease the grade to prevent the loss of tractive effort due to the curve. So in curve, there will be tractive effort loss. So for that reason, we need to decrease the grade. Grade should be decreased so that the tractive effort can be, the loss can be prevented. All right. So that's what is the grade compensation. And the grade compensation is generally between two value. Minimum of two value is taken. 30 plus R by R, and another is 75 by R, where R is the radius of the horizontal curve. Okay. So if there is a gradient and a horizontal curve as well, we need to decrease the gradient so that the tractive effort produced by the engine will not get lost furthermore, because already in curve the tractive force will lose, but furthermore the gradient can also cause the loss in the force. That's why to prevent that loss we need to compensate the grade, we need to decrease the grade, and that decrement in grade is known as the grade compensation. So in question we have given as the ruling gradient is 5%, 1 in 20. The radius of the horizontal curve is 100 meter. So what is the compensated grade? So we know that compensated grade is maximum of 2, right? That is 30 plus R by R equals to 30 plus 100 by 100. That means this will be 1.3%. And another is 75 by R, that is 0.75%. So which is more? Which is more? Which is less? Sorry, which is less? We have to take the minimum value. That is 0.75 is less. That's why our grade compensation is 0.75. So the compensated gradient will be compensated gradient equals to 5%, 0.05 minus 0.075. Like 5% minus 0.75%. That will be 4.25%. Okay, and this is the compensated gradient. Only this numerical can be asked in this type of question. So another, okay, let us continue our chapter furthermore. So another question is, what are the types of gradient? So this is a very important thing. What is grade? Obviously we know that what is gradient. Gradient is the rate of rise or fall of the road with respect to the horizontal along the road, right? Road along the road portion, the rate of change of rise or fall, right? It is known as the gradient. We know that gradient is simple theta or 1 by n. 1 by n equals to tan theta, simple as that. So what is the first one? The first type is the ruling gradient. Ruling gradient is the maximum gradient within which the designer attempts to, always the designer always attempts to design the vertical profile in a minimum. As far as possible, the minimum gradient should be provided. because obviously the vehicle cost, maintenance cost will be less, the power of the vehicle can be easy, there will be comfort. That's why the ruling gradient, the designer always tend to make the gradient as far as possible it should be minimum. Okay, so permissible gradient limit uh, should be there, and at that limit the designer should design the gradient, and it depends upon the terrain, design speed, power of the vehicle, and also the length of the grade. We shouldn't provide same gradient along a long same gradient along long span of length. We shouldn't provide it because it will cause it won't be that great. It will cause the vehicle power to decrease along the length of the grade, like we explained about the momentum grade. So we always try to provide this momentum grade in shorter span of time, then after that we provide the straight portion, and after that momentum grade, like that wise the driver doesn't need to change the speed, change the gear every now and then. So that's why we don't provide the gradient along a long span of length. We provide a bit steeper gradient and then straight portion, and steeper gradient and then straight portion, like that wise we need to provide the gradient. Okay, another one is the limiting gradient. What is limiting gradient? Limiting gradient is if the gradient, mainly the limiting gradient is used to provide when while providing the ruling gradient, we need to have some earthworks. That means we need to cut and fill some portion, right? Like if I have to provide this kind of gradient and the topography is like this, then it will be okay because the cut and fill ratio is it's good. But if the topography is like this, and we need to provide the gradient like this, then the cut will be more, the cost will be more, but the feel is very less. So there will be more earthquake activity. We need more time, we need more cost on cutting this terrain. That's why it will be not economic. So from the economic point of view, the designer increases the gradient to maximum gradient. So that's why the designer increases the gradient to maximum gradient so that the construction cost can decrease, and this is known as the limiting gradient. And limiting gradient also is not provided in long stretch. We know that there is no particular length up to which the limiting gradient should be provided. And another one is the exceptional gradient. So what is exceptional gradient? Exceptional gradient is while designing a gradient, we may encounter a lot of structure that may hamper our gradient value, like cross drainage structure. We have discussed about it in we should we are well uh, you should have read it in irrigation as well. So there will be cross drainage structure, and for that cross drainage structure we need to you know increase this elevation significantly. And on increasing this elevation significantly, the change in gradient should be more than the limiting gradient, and it will be more, that is 12% is the maximum gradient that we can provide. And the maximum gradient, the maximum limit can also reach while providing the exceptional gradient, and this is known as the exceptional gradient. We need to provide the more gradient than the maximum gradient, that limiting gradient. We need to provide the gradient more than the limiting gradient, because in the causeway the cross drainage structure will occur, and we need to increase the gradient. That's why we need to provide the gradient. Okay, that is known as the exceptional gradient. And what is minimum gradient? Minimum gradient is in road. The road should not always be only straight plane, because there at the side of the road there is side drain as well. Okay, and the side drain should be used to flow the water towards the downstream. But if the road is almost straight, almost plain, then then the water in the side drain will not flow towards the downstream. The water in the side drain will remain in there, and it will cause many impact. That's why there should be minimum, the road should be provided with a minimum gradient, such that the drainage purpose can also be fulfilled. The drainage can also move towards the downstream, and it can go and mix in the water. That is known as the minimum gradient. Okay,